Hi, I'm Roberto, and I'm going to teach you physics. The universe pushed me to be a YouTuber, so that's why I have this catch-up phrase. I think most YouTubers have it. I think I don't know. Anyway, um, I had a kind of discussion with my son about what he's studying in school, and I was studying osmosis and diffusion, and he wanted to ask me why osmosis happens. Say, what do you mean by why? Yes, but why the solute? I don't know what's the word. The solvent. Why the solvent is moving and not why is it moving? You say it was difficult to explain to him because in science we don't know why. We just know how. Because the fact is that reality works in a certain way, and what we try to do is to explain how it happens. And for this, say, oh man, you do that with that. You say, that's not a thing, true. We use logics, and logics is based on axioms or principles. And I explained to him a classical example, like Aristotle is a man. All men are sometimes wrong. So the logical conclusion is that Aristotle is sometimes wrong. You know, that's logics that was introduced by Aristotle at least the first one that wrote about it, or was, yeah, or we think he wrote. For those people who are very purist. So apparently he introduced it in the European thinking some 2000 and something years ago, 1500 years ago. So the point is that it's a tool that is still used today, because the idea that there are things that you know, and using the things that you conclude the things that you don't know. For instance, if all men are sometimes wrong, you know that because you've seen it. Okay, Aristotle is a man. Because you know him. He's a man. And then the link between being a man and being wrong. Aristotle is being a man. So it's a conclusion. Yeah. Say, okay, it's logical, right? Yes, that's why it's logics. What's the fight? Yeah, but how do you know Aristotle is a man? I mean, he's a man. Yeah, but do you know? If it's a woman very masculine, or a hermaphrodite, or whatever you call it. Are you sure about that? Did you do a DNA analysis? I mean, it seems, I think he's a man. Yeah, it seems fair, right? Means, fair meaning the right thing, right? That's the origin of the word axiom, what it seems fair. And all men are sometimes wrong. Did you examine all men in mankind? There might be a man who never got wrong, never was wrong. For instance, I think this man should have been very boring, not to be wrong. So I mean, what color is the sky? Sky is blue unless it's gray. Do you like meat? Oh, yes, I like the meat I've tasted. But, how do you like meat? Here, have this. You're going to like it. I'm not sure. I like the meat I ate, but I'm not sure about your meat. So, I mean, in history, there might be a man that was never wrong. We don't know, but it seems logical that all men are sometimes wrong, right? So, this need no proof that Aristotle is a man. I think it's fair that all men are wrong. So science is exactly behave exactly like that. So to understand that Aristotle is sometimes wrong, the explanation How is it possible? It's because he's a man and all men are, and we use the axioms. And inside is the same. Why does this happen? I mean, why? Why? This is why we describe the how. It's a logical conclusion of some truths that we can't prove. I mean, are you doing that? Yes. But what truths are there? Are these what truths? You call it axioms. We think they are correct and we can't prove them. Tell me what are those principles? My brother said, well, there's an axiom in science that says that all systems that when they're isolated, they tend to equilibrium, and then when they reach the equilibrium, they don't change anymore. So you see, this system is not in equilibrium, and then when the concentrations are the same, it's in equilibrium. I mean, and that's it. Oh. And for instance, the conservation of energy can go, yes, sometimes applied, sometimes not always applied. And what other thing? Let me think. Oh yeah, that all particles are moving, like it's exactly at absolute zero. We are not at absolute zero. All particles are moving, so when the particles are moving, the thermal agitation or the Brownian movement, you could call it, yeah. So means that the particles are moving. So if the particles are moving, this could explain why the tendency to equilibrium is water migrating. So why are we explaining osmosis and other things? It's irrelevant. The point is that there are some axioms, right? That I say, okay, there must be an axiom to explain this. And I thought about thermodynamics and about conservation of energy. I said, okay, the second principle of thermodynamics says that all spontaneous processes have the tiger mosquitoes invaded Spain last year. We can't get rid of them. Thank you, the ones who sent them, the country who sent them, thank you. What was I saying? I don't remember. In Spanish, we say that when a fly passes by and you get distracted, like saying that you get easily distracted. As you can see, for me it doesn't work with a fly, with a mosquito. So yeah, another principle is that all spontaneous processes increase entropy in the universe. So you can probably see that in this case entropy increases. That's why this process is spontaneous. It doesn't have, say come on. But he wasn't. The worst of all was that the axioms, the idea of what axiom of principle, he wasn't accepting it. So it was complicated to me to tell him. So he said, but isn't science used to get to the truth? And say, come on, we had this discussion before. Remember in a previous video? Yeah, I always like to say that. I leave it here, I'm not going to add the link. But anyway, I'll leave you here